Hi, and welcome to today's exercise. Today we'll be talking about logarithms. By definition, the logarithm of a number to a base b is the power to which the base will be raised to give the number. For instance, we know that 2 raised to power 3 is equal to 8. Therefore, the logarithm of 8 in base 2 is equal to 3. We know that 4 raised to power half is equal to 2 from our laws of indices. Therefore, the logarithm of 2 in base 4 is equal to half. We know that 10 raised to power 0 is equal to 1 as usual. Therefore, the logarithm of 1 in base 10 is equal to 0. We also know that 10 raised to power 1 is equal to 10. Therefore, the logarithm of 10 in base 10 is equal to 1. We know that 10 raised to power 2 is equal to 100. Therefore, the logarithm of 100 in base 10 is equal to 2. We get the gist. Now, seeing that logarithms are basically exponents, we know that they will follow the rules for exponents, the laws of indices. That means to multiply two numbers, we can find their logarithms in base 10 because usually the logarithms used for calculations are all given in base 10. So to multiply two numbers, we can find their logarithm in base 10 and add the two logarithms. To divide two numbers, we can find their logarithms in base 10 and subtract. To exponentiate or raise to a certain power, we can find the logarithm of the number that needs to be raised to a certain power and then multiply it by the power. Now, logarithms in base 10 are given in 4-figure tables. As we go along in the exercises, we would learn how to properly read off the tables, get our logarithms, do our calculations, and read off the anti-logarithm tables to get back to where we started. Exercise 1L. Number 2. 14.28 times 843.7. To solve this, we set out our solution in tabular form. Here we have number, here we have logarithm. Now, the logarithm of a number comes in two parts. The decimal point divides the two parts. The part before the decimal point is called the integer, and the part after the decimal point is called the decimal fraction. How do we get the integer? The integer, for instance, in this number, we see that before the decimal point, we have two digits, that is 1 and 4. To get the integer part for the logarithm of this number, what we do is count the number of digits before the decimal point and subtract 1 from it. Here we have two digits, 1 and 4. So 1, 2. We do 2 minus 1, and that gives us 1 point. Now, to find the decimal fraction, what we do is to read off 14 under 2, difference 8. If you pick up your table of logarithms, that's your 4-figure table, you will see columns. The first column is x, followed by 0, 1, 2, 3, up to 9. Then you find the differences column. The first number there is 10 and it goes down to 99. So you go and look for the number 14 and you read it off under 2. 14 under 2 gives us 1, 5, 2, 3. Then in the same rule for 14, you go to difference 8 and that gives us 24. Now you add the two of them. This is 7, 4, 5, 1. So here you have 1.1547 as the logarithm of the number 14.28. Now the next number is 843.7. To find the logarithm of this number, the integer part, how do we find it? We have 3 digits here. We have 1, 2, 3. We subtract 1 and we are left with 2 points. Now we read off 84 under 3, difference 7. 84 under 3 is 9258 and difference 7 is 4. Once more we add. This gives us 12, 6, 2 and 9. So here we have 9262. Because we are multiplying the two numbers, we add. So this is 9, 0, 8, 0, 4. Now we have the logarithm of the answer. So how do we find the number, the real number? Because this is the logarithm of the answer. So how do we find it? We go to the table of antilogarithms. For now, forget about this integer part. We read off 0.08 under 0, difference 9. 0.08 under 0 gives us 1202 and difference 9 gives us 3. So we add, this is 5021. So here we have 1205. Now this integer part is 4. We add 1 to it. 4 plus 1 is 5. From here, we move the decimal place towards the right 5 places. That is 4 plus 1. So we have 1, 2, 3, 4, 5. Add 1 0 to complete it. So that tells us that 14.28 multiplied by 843.7 gives us 12,050. You can check that with your calculator. Number 3. $675.2 divided by 35.81. Once more, we set out our work in tabular form. Number and logarithm. Here we have 675.2. For the integer part, we have 3 digits here, so we subtract 1. So that gives us 2 points. Now we read off 67 under 5, difference 2. And that will give us 8294. The second number is 35.81. For the integer part, we have 2 digits here, so 2 minus 1 is 1 point. We read off 35 under 8, difference 1, and that will give us 5540. And since we are dividing, that means we will subtract. 4 minus 0 is 4. 9 minus 4, 5. 2 minus 5 can't go, that's 12 minus 5 7. 7 minus 5, 2. 2 minus 1, 1. Now, in the table of antilogarithms, we look for 0.27 under 5 difference 4. 0.27 under 5 is 1884, and difference 4 is 2. So we have 1886. So here we have 1886. Now, the integer part is 1. We add 1, which gives us 2. And that tells us that we are only going to move, remember the decimal point is here. So we move 1 plus 1 places towards the right. So that is 1, 2. And that gives us that 675.2 divided by 35.81 is equal to 18.86. Number 5. 409 multiplied by 6.932. As usual, number log. Here the first number is 409. To get the integer part, we have, this is just 409. We can say 409.0. So to get the integer part, we have 3 digits before the decimal point. Subtract 1. So we have 2 point. This is 40 under 9. And that gives us 6117. 6.932. Here we have only 1 digit. 1 minus 1 is 0. So we read off 69 under 3, difference 2. That gives us 8409. We are multiplying, so we add. 7 plus 9, 6. Carry 1. 2 plus 0, 2. 1 plus 4, 5. 6 plus 8, 14. Carry 1. 1 plus 2, 3. Now, for the antilog, as usual, we read off 0.45 under 2, difference 6. Now, 0.45 under 2 gives us 2831. Difference 6 is 4. So that is 2835. So here we have 2835. Now we have 3 as the integer part of this logarithm. What do? We add 1. So we have 4. Remember, the decimal point is here. So we move 4 places towards the right. So that is 1, 2, 3, 4. So we have that 409 multiplied by 6.932 is equal to 2,835. Number 7. 5.932 multiplied by 8.164 multiplied by 18.51. Number log. 5.932. Here we have only 1 digit before the decimal place. 1 minus 1 is 0. Now we read off 59 under 3, difference 2. And that gives us 7732. We have 8.164. That is 1 digit before the decimal place, minus 1, 0. Now we read off 81 under 6 difference 4, and that is 9119. The third number, 18.51. We have 2 digits before the decimal point. 2 minus 1 is 1. We read off 18 under 5 difference 1, and that is 2674. We are multiplying, so we add up everything. Here we have 5. Here we have 12. Here we have 5. Here we have 9. 2. For the antilog, we read off 0.95 under 2 difference 5. 0.95 under 2 gives us 8954. Difference 5 is 10. We add, and that gives us 8964. So here we have 8964. We have 2 here as the integer part. We add 1 to it, giving us 3. So, of course, we move 1, 2, 3 places to the right, telling us that that multiplied by that is equal to 896.4. Number 11. 3.925 squared. We set out. We have our number log 3.925. We have 1 digit here. 1 minus 1 is 0. 39 under 2 difference 5. That gives us 5938. Now we have 3.925 squared. 0.5938 multiplied by 2. We know that whenever we raise to a power, we multiply by the power. So here we have 2 times 8, 16. 2 times 3, 6, plus 1, 7. 2 times 9, 18. 2 times 5, 10, plus 1, 11. Now we read off 0.18 under 7 difference 6. 0.18 under 7 gives us 1538. Difference 6 is 2. So we have 1540. So here we have 1540. Now we have 1 here. We add an extra 1. So 1 plus 1 is 2. Remember, in this case, it is not just 1 digit. It is about the particular number that we have here. We have 1 here. So 1 plus 1 is 2. So from here, we move 2 places to the right. So that tells us that 3.925 squared is equal to 15.40. Number 17. 2.96 squared multiplied by 8.542. We set out our calculation. Number log 2.96. We have 1 digit here. 1 minus 1 is 0. 29 under 6. 4713. 2.96 squared is 0.4713 multiplied by 2. So we have 6. 2 times 3, 6. 2 times 1, 2. 2 times 7, 14. 2 times 4, 8. Plus 1, 9. 2 times 0, 0. Now we have the next number, 8.542. We have just one digit here. 1 minus 1 is 0. We read off 85 under 4, difference 2. And that gives us 9316. Now we are supposed to multiply this by this, so we add. Here we have 2, 4, 7, 8, 1. We are adding this number, which is the logarithm of this, to this number and this one, and this number. These are the two numbers we are adding. So now, to find the final answer, we go to the antilog tables and read off 0.87 under 4. 0.87 under 4 is 7482. Difference 2 is 4. So that gives us 7486. So here we have 7486. The number here is 1. So we add 1 to it, and that gives us 2. And as usual, from here we move 2 decimal places to the right. So that tells us that 2.96 squared multiplied by 8.542 will give us 74.86. Number 19. $3.172 multiplied by 19.86. As usual, we set up our calculation. Number, log, 3.172. We have only one digit here. 1 minus 1 is 0. We read up 31 under 7, difference 2. And that gives us 5013. The next number is 19.86. We have two digits here. 2 minus 1 is 1. We read off 19 under 8, difference 6. And that gives us 2980. Because of the multiplication, we add. This is 3991. Now we are told to find the cube root of that. So, cube root of 3.172 multiplied by 19.86 is equal to this, divided by 3. 3 into 1, 0. Into 17, 5. Into 29, 9. Into 29, 9. Into 23, 7. So now we find the antilog of this. That is 0.59 under 9, difference 7. And 0.59 under 9 is 3972. Difference 7 is 6. So that gives us 3978. So we have 3978. We have 0 here. we add 1 to it, it gives us 1. So from here, we move only one place to the right. And that tells us that the cube root of 3.172 multiplied by 19.86 is equal to 3.978. Number 31. Fourth root of 83.67. We set out our calculation. We have number log 83.67. Here we have two digits. 2 minus 1 is 1. 83 under 6, difference 7. And that gives us 9226. Fourth root of 83.67 is 1.9226 divided by 4. 4 into 1, 0. Into 19, 4. That is 16. 19 minus 16, 3. 4 into 32, 8. 4 into 2, 0. 4 into 26, 6. Now, in the antilog table, we read off 0.48 under 0, difference 6. 0.48 under 0 is 3020. Difference 6 is 4. So we have 3024. So here we have 3024. We have 0 here. 0 plus 1 is 1. So we move the decimal point only one place to the right. So this tells us that this is equal to 3.024. Number 37. Square root of 3.892 cube. Once more, we set up our table. 3.892. Here we have only one digit. 1 minus 1 is 0. From the table, we read up 38 under 9, difference 2. And that gives us 5902. We have 3.892 cubed as 0.5902 multiplied by 3. And this gives us 6027 17. Now, 3.892 cubed is that divided by 2 because of the square root. So we have 2 into 1, 0. 2 into 17, 8. 2 into 17, 8. 2 into 10, 5. 2 into 6, 3. Now, from our table of antilogarithms, we read up 0.88 under 5, difference 3. 0.88 under 5 is 7674. Difference 3 is 5. So that gives us 7679. So that is 7679. We have 0 here plus 1, 1. So from here we move only one place towards the right. And that tells us that the square root of 3.892 cubed is 7.679. Number 43. Cube root of 65,210 divided by 8.673. You set out number log. We have 65,210. Here we have 1, 2, 3, 4, 5 digits minus 1, 4.65 under 2 difference 1. 65 under 2 difference 1. And that gives us 8143. We have 8.673. 1 digit before the decimal point. 1 minus 1 is 0. 86 under 7 difference 3. That gives us 9382. Because of the division, we subtract. This 3 minus 2, 1. 14 minus 8, 6. 10 minus 3, 7. Carry 1 from here. 17 minus 9, 8, 3. Now we have cube root of 65,210 divided by 8.673 as that divided by 3 because of the cube root. 3 into 3, 1. Into 8, 2. Into 27, 9. Into 6, 2. Into 1, 0. From our antilog tables, we read off 0.29 under 2 difference 0. And that gives us 1959. Here we have 1 plus 1, we have 2. So that is 1, 2 places to the right. So that tells us that the cube root of 65,210 divided by 8.673 is 19.59. Number 49. Seventeen 0.2 squared multiplied by 4.93 divided by cube root of 6,750,000. Number log 17.2. We have 2 digits before the decimal place. 2 digits minus 1. 1.17 under 2. That gives us 2382. 17.2 squared is 1.2355 multiplied by 2. That gives us 2 times 5 is 10. Carry 1. 2 times 5, 10 plus 1, 11. Carry 1. 2 times 3, 6 plus 1, 7. 2 times 2, 4. 2 times 1, 2. Now we have 4.93. We have only one digit here. 1 minus 1 is 0. 49 under 3. And that's 6, 9, 2, 8. Since we are multiplying the 2, we add. So we have 8, 3, 16, plus 1, 3. So we have this. Now we have 6,750,000. Here we have 1, 2, 3, 4, 5, 6, 7 digits. 7 minus 1 is 6.67 under 5. That gives us 8293. And cube root of 6,750,000 is 6.8293 divided by 3.